The first question is, how do you see the intersection of commercial weather data and public institutions evolving to advance atmospheric science over the next 3 to 5 years? And we'll start with,
Sorry.
go ahead. We'll actually start with Mitch.
Hey, so during my introduction, you heard that I used to work at NOAA, but I used to work for NOAA for like 30-something years. So it's been a long, long time. And so I joined City College, New York, just a year and a half ago. So it's been a big transition. So just to be called professor, like I said, professor, and I go, who are you, who, is that me? And so it's a good question. And what I've learned recently, or over the last year and a half, that at academia, and I'm with an engineering school, and so we have really smart students and postdocs, and it's incredible what they can do. You can tell with all this AI machine learning work, it's really being done by mostly young people because they're really, we have to give them the guidance. The older people, I still listen to Bill. He's been around for a long time, and so it's you still need some guidance from older folks like myself, but you can talk to these postdocs and students and say, "Hey, this is the big picture. This is what we want to do," and it's amazing what they think of, and so we can really come up with outstanding solutions. I think over the next 3-4 years, it's still going to change over the next 3-4 years. This excitement of AI data-driven. I mean, I didn't even know what that meant 5 years ago, and now I do. And all these tools that are available, people are providing community tools. So I always think of AI machine learning, if you can imagine it, and you think of the data and think what's correlated, you can make it happen. So in terms of being in academia, it's amazing the talent, the freshness of the people thinking of new ways of doing things. Like, it's just incredible, the access to the talent pool. And I think that's true across all of academia. Just the talent's out there. And so it's going to be, and just providing exciting data, just to inspire the students when you talk about this and CubeSats and data, the high tempo refresh is so important. They really get excited by this data. And also when you tie it, like you did, the video is great. When you tie it to, not just doing retrievals or forecasts, but why it really matters to society, the impact-based activity. Social science is a big area. I mean, resilient communities, vulnerable communities, rich and poor, as mentioned, they really get that too. So in academia, we're really focused on not just the technology, but also the social science aspect as well. So it's very exciting. I mean, 5 years ago, I didn't even know what social science was, right? We didn't care. We just cared about if our retrieval error was improved by 0.3 of a degree. But knowing what it really means to society is really, really important these days. Thank you.
Thank you. Over to you, Marc.
So Marc Gasbarro, I've retired Air Force weather. Joined NOAA about 3+ years ago, and now over at the NESDIS Commercial Data Program Office, where we focus on buying commercial data for space-based environmental monitoring purposes. And we have two lines of effort. One is purchases, operational purchases, which currently that's just the radio occultation with Spire, Global, and Planet IQ. But we also do pilots. And we've done multiple pilots. We piloted radio occultation back in the day in the late 2010s, started in 2016. Then we grew, moved that to operations. And we did a pilot for space weather, space ionospheric measurements using radio occultation. We're working to try to figure out what's next with that. I think we got some way forward. Did a reflectometry with GNSS reflectometry measurements with Spire Global, but there's other companies like Muon Space that's rapidly catching up with that. And then now we've gone a whole different direction, and for the first time, we're doing something that's not GNSS based, and that's microwave. So it's a whole different. We are the Commercial Data Program Office, not the Commercial RO Office. So now we have a new pilot that we've awarded to Tomorrow.io and Orbital Microsystems. So we're very happy to have them on board. For commercial data in general, The bottom line is this: for the next 3 to 5 years, and I'll even go beyond 5 if you don't mind me here. But commercial is growing. There's an insatiable appetite for data, more data, and there is a growing need for perishable weather data, not just within the governments, but the international governments, WMO centers, private enterprise, you name it. Government satellite systems do an excellent, phenomenal job, but they're not enough. There's a lot of gaps in the network right now. You think of microwave, you have what's flying on our JPSS satellites, and then you have MEDOP. Phenomenal, resilient satellites that can last a lot longer than what commercial platforms can provide. So government satellites are more resilient and they can provide more bespoke on-orbit options. However, there's a lot of gaps. And those government systems are a long lead to build, whereas commercial offers greater flexibility, much shortened acquisition timelines, rapid deployment, and the bottom line is they can provide a lot more data rapidly. So NOAA sees a working relationship between commercial and government. One is not going to replace the other going forward. It's always going to be a supplement to the NOAA government backbone, but it's a viable and pertinent supplement.
Yeah, thanks. First of all, also a huge shout out to the video. I mean, I'm inspired after watching that. I feel like I want to go home and write some code, bring it to reality. Now, to get back to the question, and I'll just calibrate a little bit, I think with how rapidly we're seeing the field change, even asking me, what do I see as the future in 3 to 5 months might be a tough question to ask, right? Things have just changed so rapidly. But I will keep my answer a little bit short, and I'll double down on something that Marc said, that really the ability, sorry, I'll keep the mic a little bit closer. The ability of Tomorrow I/O to get birds in the sky, you saw with the sounders, those went up in August, another set of launches in December. It was a couple weeks until the data was actually calibrated, science validated, and ready operationally in our systems, driving our weather forecasts, which are available to customers, right? We're a satellite or a software as a service company. We're trying to deliver predictions that do improve people's lives, their ability to act as businesses. And it's really remarkable to be able to get that information back from space that rapidly. When we see the future of being able to determine what kinds of observations are essential, we'll have the tools now, I think, through AI, ML. It'll become much more accessible to decide what types of observations are really going to help lock down a forecast. That can be done dynamically as well, and we can rapidly build and scale observing systems that support that kind of information. So I'll just stop with that.